So this is now considering the quadratic formula. What is the quadratic formula for calculating the roots of the quadratic equation? It's x equals what? Negative b plus or minus square root of
b squared minus 4ac
yes
over 2a.
Awesome. Okay, that's our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now if I was to write them as two separate statements, because at the moment with this plus and minus in here, it's kind of combining two into one. So I'll just take the negative out of there and I'll write it again over here with the minus. So it's telling us there are actually two roots of a quadratic equation, quadratic function. One is at negative b plus this thing, which we call the discriminant, the square root of b squared minus 4ac over 2a. The other one is negative b minus the discriminant over 2a. So there are actually two roots, as we've seen for many quadratic functions, where it crosses the x-axis twice. And we said before that the midpoint of the quadratic function is halfway between those roots. It's the x value at that midpoint is the average of these two. So let's do that. Let's find the average of these two. So the x at the axis, that's what we're saying here, the x value at the axis is negative b plus the square root, and just for ease, I'm just going to leave that blank, but we know that's in there, over 2a. And to find an average, you add the two together and divide by 2. So I've added that root and that root, this one up here and this one up here, that root and that root, add them together, divided by 2. Okay? Now I've got two fractions with the same denominator. How do you add those two together? Just add the top. Do you do anything with the bottom? No. So if I'm, again, looking at the numerator of the big fraction, within that I've got two fractions again, but I can add those two together and put them both over 2a, and it's still sitting over 2, that's the 2 here, but I'm going to add this and this together. So what have I got? I've got a negative b plus a negative b. What does that give me? Negative 2b. And I've got a plus this square root and a minus this square root. When I add those two together, what have you got? 0. I've got nothing in that case. So I'm actually finding the average of those two. I'm adding those two together. So I've got this thing here. I've got a positive version of this square root and a negative version of this square root. And when I've got a positive of one thing and a negative of the other of the same thing, and I add them together, 0. Plus 3 plus negative 3, 0. Positive 5 plus negative 5, 0. Positive x plus negative x, 0. Okay? That's all I'm doing. A positive of the square root and a negative of the square root, add them together, what do I get? I get nothing. So in fact, I can just write this negative 2b here, and that's it. Negative 2b over 2a, and then that whole fraction over 2. Can I simplify this top fraction? Minus b over a, all over 2. And what do we do when we have a fraction in the numerator? We just multiply the two denominators together. Equals negative b over 2a. And that's what we've got, isn't it? Our axis of symmetry is at negative b over 2a. So that's the proof of why that is the case. And it's a neat proof because it actually comes out to this really nice result which we can easily look at, negative b over 2a. So for any quadratic function that's written out in its expanded sense, not in brackets, expanded sense, we can easily and quickly get its x value of the midline by looking at negative b over 2a.